Hi, my name's Joel Tax. I'm with Reserve Data Analyst, and this presentation is going to go into the fully funded balance calculation in the reserve study. The topics today, what is the fully funded balance? Risk of being underfunded, less than the fully funded balance, and other considerations for the fully funded balance calculation. So what is the fully funded balance? Essentially, it's a calculation of an ideal amount in the reserve account which offsets the accrued deterioration of the component. Now this is calculated annually at a specific point in time, and it will change from one year to the next. It's important to note here what the fully funded balance is not. It's not the full project cost of the component. It does not equate to a number that equals the cost to complete the project. It essentially just means you're on track for paying for that project at a specific point in time. And the formula for this is a pretty simple formula. It's the component cost, that's the current component cost, times the component current age, divided by the component useful life. So an example here of this formula is we have a $100,000 paint project which is 1 year old and has a paint useful life of 10 years. So at the end of 10 years we're going to have to recoat the paint. So in this scenario the formula is $100,000, that's the paint project cost, times 1 because it's 1 year old, divided by 10 because the useful life of the paint is 10 years. And that's equals to $10,000. So the fully funded balance at the end of year 1 for this paint project is $10,000. Now let's look at an example here of a community or organization that's allocating 100% of the fully funded balance into the reserve account. So in this case we have again this $100,000 paint project that has a useful life of 10 years. And we're going to ignore interest and inflation here for simplicity's sake. You can see at the end of year 1 they've allocated $10,000 into the reserve account. They are 100% funded, and that is also the fully funded balance. This $10,000, that means they're on track for paying for this paint project at the end of 10 years, which equals $100,000. Now the reason we're saying they're on track is because they have equally dispersed the cost over the 10 years. So every year they're depositing $10,000 into the reserve account. They're not fluctuating. At the end of year 2 they have $20,000 in the reserve account. The end of year 3, $30,000, so on and so forth. Until the end of year 10 they have $100,000 in the reserve account, which equals the amount of the paint project expected cost. Again, we're ignoring inflation here just for simplicity's sake of the math. In this community, they have deposited into the reserve account an amount equal to the fully funded balance. In year 1, the fully funded balance is $10,000. In year 2, it's $20,000. In year 3, it's $30,000, and so on and so forth, until the final end of year 10, the fully funded balance equals the cost of the project. That's the only time that the fully funded balance will equal the full project cost, is at the end of the useful life of the component. Now let's look at a different scenario. In this case, this community is allocating half of the fully funded balance into the reserve account in each year. So in this case, they are depositing $5,000 into the reserve account instead of an ideal amount of $10,000, which is also the fully funded balance. It's important to remember the fully funded balance is an idealized calculation. It's the amount that if we were to disperse the cost equally over time, it would offset the deterioration of the component, and at the end of the useful life of the component, the fully funded balance equals the cost of the project. So in this case, they're depositing half of the fully funded balance, $5,000, in year 1. In year 2, another 5,000 to have a total of 10,000. In year 3, they have a total of 15,000, and so on and so forth, until year 10, when there's a significant shortfall at the end of year 10 because they have under budgeted the reserve account. They have deposited less than the fully funded balance into the reserve account for the prior 9 years. The project cost is still going to happen. It's up here at $100,000, so they're going to have to come up with a way to raise funds and place them into the reserve account to pay the paint vendor. The fully funded balance at the end of year 10 is $100,000. They only have 40 or 45,000, depending on how you want to cut this off here. Essentially, the community members in year 10 are having to make up for that deficit or that shortfall in the reserve account. And that's something we want to prevent. We want to disperse those costs over time, so the deterioration of the component equals the fully funded balance, and the amount being deposited into the reserve account is as close as possible to the fully funded balance. That means everybody is paying their fair share into the reserve account. Now, in a real life scenario, we're not just dealing with one paint component, we're dealing with many components with different ages, with different replacement years, with different useful lives, different remaining useful lives, and different costs, unit cost and total cost here. As you can see here, this $165,000 figure, that's the total component replacement cost. If you were to replace all the components now, that would be the cost in this particular community. That is very different than the fully funded balance, which, as you can see, is significantly less than the full cost to replace all the components. This is the amount that represents that they're on track for paying off the project cost over time. It is not an amount that equals total project replacement at this particular point in time in this community. That's important to note. There's a huge difference there. They are not the same number, and they shouldn't be intermingled with one another. Some risk of being underfunded include cash flow issues. Underfunded essentially just means you've deposited less than the fully funded balance into the reserve account. As time goes on and component projects need to be completed, there just isn't the money in the reserve account. Another risk is deferred maintenance and deferring projects. That is the direct result of depositing less than the fully funded balance into the reserve account. Now we use a cash flow method of calculations, so that has kind of a built-in margin of error when we have many components. But the fewer the components the community has, the closer we need to be to the fully funded balance in any particular year, or else there is definitely going to be a deficit. Marketability and aesthetic issues. When the fully funded balance is not reached and there isn't money in the reserve account to pay for these projects, oftentimes they're deferred. When they're deferred, things start to look aesthetically unappealing. You may have peeling paint, you may have a tarp on the roof, you may have a siding that's rotting, you may have potholes in the asphalt. Whatever the case is, those all have an impact on the current membership and any potential buyer that comes into the community. Other considerations for the fully funded balance include the fully funded balance is calculated annually. It takes into account current cost and inflates that over time. We utilize 3% inflation, is pretty typical. It's also important to note that the fully funded balance will fluctuate over time based on the component projects that have been completed or that have been deferred. They will again fluctuate from year to year. The fully funded balance is not the full picture. We also want to make sure we look at the cash flow projections in the reserve study. We want to see the actual reserve account balance, not just the fully funded balance. It's important to remember that the reserve study is a full document with many aspects to it, and we want to read all of it to get a full picture of the scenario in your particular community or organization. Having less than the fully funded balance may not lead to a deficit or having $0 in the reserve account. Again, we utilize a cash flow method, which is essentially we make a pool of money for all the components, and we remove money from the reserve account to pay for those projects as they come due. Essentially, it's a snapshot in time of the cost. And we'll have a different presentation about the cash flow method that I suggest watching. And you should be very cautious of mathematical gimmicks. It's very easy to change the fully funded balance simply by changing a cost of component, useful life of component, remaining useful life of component. Those items can have dramatic impacts on the fully funded balance, and we want to make sure that they're accurate and real life scenarios, not just something that's being done to make something look good on paper. It's very easy to create a budget on paper that looks great and get away with it for many, many years, sometimes even decades, before the real project cost happens, and then it becomes obvious that the reserve account has been underfunded, usually because there is an inadequate component list, or there essentially is gimmicks being made to the math by changing the numbers to make things good look on paper. So that's about it for this presentation. Hopefully it was helpful here. Please call or email with any questions, and we look forward to working with you in the near future. Thank you.